Hello, this is Rui PCB, your trusted PCB partner. Today, we will continue introducing the PCB design tools in KiCad. In the previous episode, we already covered the tools on the left toolbar. Today, we'll continue with the right toolbar. The first tool on the right toolbar is the selection tool. We're already very familiar with this one, as it has been introduced in both the schematic and footprint library. The second tool is unique to the PCB and is called the local flywire tool. When the flywires are hidden, you can use this tool to select a footprint and it will display the flywires for the selected footprint. For example, right now we have the flywires hidden. If we select a footprint, it will show all the flywires for that footprint. You can also display the flywires for a specific pin, which makes it clearer when routing traces. When all flywires are turned off and we want to route a specific pin, we just select it and it will show you which other pins it connects to. This way, you can more accurately find the routing path. Next is placing a footprint. This works similarly to placing a component in the schematic. Select a footprint to place and then just put it here. However, I don't recommend doing it this way. If you need to add components, it's better to make the changes in the schematic and then import them into the PCB. Don't just make changes in the PCB, because if the schematic isn't updated accordingly, it can lead to errors. Of course, you can also update the schematic from the PCB, but this process is prone to mistakes. Since the functions of each pin aren't clearly indicated here, it's still easy to make errors, so I don't recommend this approach. This is the routing tool. Similar to the schematic, these are all pretty standard. Let's draw another trace. When you select it, it will automatically highlight, and that's how you finish drawing a trace. Next, this is called the length adjustment tool. We select it, then choose the trace we want to adjust, and by clicking it, the trace will automatically be extended or shortened. We can also, let's ignore the increase and decrease options for no and directly click set length. For example, if I want to set it to 40 millimeters, I just click OK, and you see it will automatically set the trace to a length of 40 millimeters. The main purpose of this is for drawing things like differential pairs or match length traces in the future, where certain nets require equal length, and you can use this tool to adjust the trace length accordingly. Next, this is the via tool. What a via is used for. Right now we're working with a double layer board. When a trace is blocked and can't get around, for example, let's say we're drawing this trace, let's first select the trace tool. Of course, we could route it from the other side, but if that's not possible, we can first choose to draw a segment to lead it out, then place a via, and after that, switch layers and continue drawing the trace. In this way, we've completed the connection for this trace. A via is used to connect different layers, allowing them to conduct with each other. The same applies when working with multiple layer set, enables the inner layers to be connected as well. Next, this is the copper pour tool. Generally, we use it to locally pour copper for ground or high power power supplies. If there are no high power power supplies, then when we finish the design, we can pour copper for the entire PCB ground. This can improve signal quality and also reduce the amount of work needed to connect ground lines. So when we're routing, we don't need to draw the ground lines separately. For example, when we design copper pours, the copper pour must be a closed shape. First, select the layer, then select the net, choose GND, and then click OK. Now I start drawing this shape. Usually, when drawing at the end, you just need to enclose the entire PCB. Be sure to close off the shape at the end, and then the copper pour area is finished. The next one is called the rule area, which is similar to drawing schematics or footprints. For example, in a certain area, I want to prohibit routing or prevent certain components from being placed. and you can select the specific layers as well. It's just like copper port. Let's assume we temporarily create one in this area. So what is this mainly used for? For some cases, especially with wireless antennas or wireless modules, the antenna area or within 1 centimeter of the antenna on the PCB is not allowed to have copper pore or routing. So after placing the components, we can set a restriction rule in this area to prevent us from forgetting this rule while routing and avoid pouring copper there, which could affect the overall functioning of the PCB. The remaining ones are the tools we've used before in schematic diagrams and footprint libraries, like drawing straight lines, arcs, and rectangles. These are all graphic tools and are different from routing. They're mainly used for drawing various symbols and markings. This one here is for importing images, and these are for placing text boxes, and tables. We won't demonstrate each of these one by one. And this one is the measurement tool, which we usually use. So let me explain it a bit. We generally don't place the measurement tool on the same layer. Let's put it on the silkscreen layer. For example, when we're done designing the board, we might need to measure the board's length or the spacing between certain components. We can pull out the measurement tool and place it on the PCB, which makes it easy for us to check and confirm the dimensions of the outline or the spacing between specific components at any time. And this one here is also a delete tool. If you want to delete something after selecting it, just click delete and that's it. Well, we've now finished introducing all the tools on both the left and right toolbars of our PCB tool. If you enjoyed this video, please subscribe to my channel for more content. Thank you all.